Everyone.
Okay.
Myself Deepak Sharma from CSIT Durg. I take this privilege to welcome Dr. Ashwini Kothari sir, professor from VNIT Nagpur. Today, sir, am I audible?
Yes, yes.
Okay. Thank you, sir. So today, sir is going to give a lecture on data and pattern classification using rough set. So I welcome you once again on behalf of the organizing team from CSIT Durg. So, sir, you can share your presentation and you can start the lecture, sir.
Thank you.
Thank you,
I
sir.
would start now my presentation. Just to save bandwidth, I will switch off my cam. Uh, am I audible?
Yes, sir. You are
Yeah.
clearly audible.
Is my screen visible?
Yes, sir. It is visible perfectly.
Okay. And are slides changing?
Yes, yes, sir.
Okay. Okay. Thanks a lot. Very good afternoon to all. And we are here, or my topic today is basically data and pattern classification using rough sets. So giving a view for rough sets as a new tool or an interesting tool to be used in the field of AI and ML, and particularly not as a competitive but as a complementary in a complementary role. As the title of the STTP is Recent Advancement in Artificial Intelligence and Machine Learning. So the conventional types of neural networks and its expansion into various other types and all we know, and also for development of AI methods or AI based methods or machine learning based methods, how we incorporate these algorithms and all we know. But there are various other computing tools also which have a lot of interesting features, and how they can add up to the power of AI or ML collectively if they are used in hybridized manner and all that I would discuss. Now, before I start with my formal talk and all, I would just like to take you for a 5 minutes uh, round through the center of excellence which our department has, and various facilities which are approachable, accessible for others also, and which can open opportunities or can provide opportunities for collaborations in terms of academic and research activity. So this is the picture of our department where this center of excellence is hosted. And in 2013, in the first phase of TechWhip, this Center of Excellence in Combedded System was provided to our department. So combedded system is the term which is actually hybridization of communication and embedded system together. And these are the main five objectives of Center of Excellence. So one is IP development through filing patents and publications, actually research publications. Then we have a state of the art lab. At this juncture, we have almost around more than 7.5 to 9 crores of equipments, including software and hardware tool. So various advanced kinds of equipments and computing tools and facilities are there, so which can be used for the R&D or product development and prototyping activities. So usually the incubation facilities are also provided to innovative UGPG projects which can further be developed into some commercially viable products and all. Then we have academic and industry collaborations also. So many industry partners are there, and we have MOUs with institutions, universities abroad of repute and or of national or international standard. And last but not least is we conduct on regular basis the enhancements, workshops, seminars, or certificate courses also. So you will find that these are the various topics or projects basically which amalgate many technologies together, and in this field we are working. And these kind of products related to assistive technology or robotics or you see security surveillance or medical healthcare using IoT and all are involved. So basically, you will find that, or there are various projects which are of socio-economic relevance also, which we are developing. And these are the glimpse of such prototypes which have been developed and all. So that may be in the field of right from antenna to robotics, AI, ML, or healthcare, or whatever it is there. Now, this competent system center of excellence is there, is conducting courses in the field of wireless communication, embedded system, and then you will find that radio frequency circuit design, AI, ML. There are various topics which are there on which these courses are run. The peculiarity of these courses is who can attend it. So anyone who has completed the second year of engineering, he may be a PhD research scholar or a faculty or a BSc, MSc student or BTech, MTech engineering student or industry professional. For all of them, it is useful. The courses have no theory, element of theory, hardly 1 or 2 lectures, and the complete emphasis is on the hands-on experience and more of lab exposures or skill enhancement related to various tools and all. So therefore, if you are a faculty and you go through various courses, it can do value addition to your teaching delivery. If you are a PhD scholar, then it can help you in your research and all. So these are the salient features for which these courses you can do. And generally, you will find that these are the various fields of in which the courses are available. Even now, the CS-oriented courses are also added into it, and all the courses are at basic and advanced level. When normalcy is there, like right now, the situation of pandemic is there. Again, cases are increasing, so we have right now given a halt. But in normal situation, on 4th and 15th of every month, the batches are conducted, and the modules are from 30 hours to 60 hours duration courses are there. So 2 hours per day, like that it is there, and on demand the accommodation facility can also be provided. Or sometimes during vacation time, the outstations candidates can complete these courses in crash course manner. So within a week, spending 8 hours daily, they can finish off the course and all. And the resource persons are the faculties, my colleagues from VNIT, some industry experts and lab engineers of Center of Excellence. These are our industry partners, and the venue is the department itself. We don't provide direct placement assistance, but the way the skill enhancements are done, it can definitely enhance the employability quotient of the students. So you can see the fee structure is also in the range of 3,500 to 4,000 only. So different course modules are there, and even the courses in computing with MATLAB, big data, parallel computing also have started. These are the glimpse of the labs of Center of Excellence, where all these advanced equipments, environment, test instruments, or computing facilities you can avail and can check out the things. These are the contact credentials which are available on the VNIT website also. My email ID is also there on the department page. So anybody, anyone in individual or group capacity, whatever way wants to basically approach for this thing, they can contact me. So thanks for giving your 2 minutes and patient hearing to this particular thing, because we wanted to propagate that these courses are available, and you in individual capacity or as a group, you are always welcome. So you can plan in normalcy to come and go for hands-on sessions and all. So now I will start with my formal topic, that is nothing but data and pattern classification using rough set. So you will find that usually in AI ML, the most important thing which is always done is knowledge discovery database, or it is KDD, which we always do. In general, you will find that its two substeps or intermediate processes are popularly known. One is nothing but the data mining, which is there, like in this case we explore the data, or we do the discovery of data, or we want to get metadata, that is data of data, and from that we try to explore the hidden patterns inside the data. And the second part is the knowledge interpretation or inference drawn out of that data. So these two activities, when are combined together, the overall process is called as knowledge data discovery or KDD. So all the AI, ML, data analytics, whatever these tools or technologies are there, they're all focused towards main objective of KDD only. That is knowledge data discovery. Now, in that case, in substep, like when data mining is there, there are various things like data pattern recognition, pattern classification, or exploring the data. These kind of steps can be involved. So one picture is worth of 1,000 words. In a very simpler way, if KDD is to be explained, it can be explained like there would be a huge raw data. Now here, when on the left hand side this particular huge raw data has been shown, it can be a tabled or tabular data, or it can be in terms of strings, text, it can be images or audio recordings, whatever way. The type or the format of data is immaterial, but huge raw data can be there. It can be like the details of the traffic on the internet, or particularly the access pattern of the users on the net to surf through various sites and all, and it can be searching history or whatever way. So when you get such huge data, then you will find that to do the total KDD, that is interpretation and data mining, in that data mining there are two sub processes again. First part is pre-processing, which is this white block. You can see here there are many important steps or processes involved in this particular stage. So there is data has to be cleaned, like denoising has to be done of images and all. So it is cleaning or cleansing of data. Then there can be augmentation of data, there can be condensation of the data, there can be reductionality of the dimensionality of the data, because then it would become very complex. So you can reduce number of attributes required for classification and all. It can be data wrapping also, or the description can also be there if you are using technique like fuzzy and all. So the description also is required. So as soon as the raw data passes through this particular block, the output would be nothing but a pre-processed data we would get. So for example, if it is image, we can do denoising, conversion from color to gray, or resizing, cropping, whatever various operations can be there, and we can get the required data in a processed manner in the required format. After that, what we have to do is nothing but is machine learning, or of which this particular STTP is going on. Under machine learning, generally what majority times we do is the classification, and then if it is a huge data to be clustered or arranged in terms of compartments and all, so we may have to generate rules also, so there can be rule generation and all. And therefore what happens is, after cleaning, when we get pre-processed data, that too also classified and clustered and all, then at this stage particularly you will find we get a mathematically modeled format of data. So your entire data will get mathematically modeled, classified, clustered, whatever way you call, and the job or the process of data mining is over. But still you are halfway, KDD is not complete. Now what happens is, you got the information, but what is the inference from it? For example, if we are doing an experiment in the lab, we get the reading, but from that reading, now what is important is inference. Finally, characterization of the data should be done. So inference is called as knowledge extraction or knowledge interpretation. So our final outcome should be this blue block or box in which it is written useful knowledge that we want. So that you get only after extraction of knowledge, evaluation, or is assessment or interpretation, from where you will get it by processing the mathematical modeled data which you have got after classification or clustering. So when data mining and when interpretation of knowledge, both things are done, then in totality we can say that the process of knowledge data discovery or KDD is complete. So that's why you will find that this classification has been shown specially in red color, because our discussion today would be focused more on the technique of classifications and how the hybridization of different tools or conventional tools of neural network and all are, when combined with other techniques, can give you better results and all. That would be the main focus of the talk. So overall, if a bird's eye view is seen for the activities concerned with AI and ML, then you will find that hybridization approaches for classification is very, very important. Now, basically, why in current scenario the data mining is so much important, or why it should be paid so much significance? So, main thing is everywhere digitization has taken place, and this has made for us a very easy task of data storage as well as capture also. So you can see hardly a 300 rupees pen drive can store 8 GB or 32 GB of data in that small stick. So you will find that fairly the storage has become simple, retrievable, and therefore you will find that huge amount of data is not a big challenge anymore, or it is rather has become a need or a kind of indirect compulsion. Then you will find that rapid computerization, automation, and this increasing size of the network like internet and all has resulted into collected of stored and centralized or distributed databases, and that too this data is of heterogeneous nature, so it can be mixture of text, symbols, numerical symbols, or texture, or images, or everything, audio, video, whatever it is there. And it can be very huge or large, not in terms of size but also in terms of dimension also, and it can be there in very scattered manner. So you will find that the rate at which this particular data storage is to be stored and all is increasing phenomenally, and therefore daily lot of challenges are there. Secondly, you will find that at the same time, techniques like AI and ML are also evolving, and therefore you will find that these techniques are getting proved as robust, efficient, accurate, error-free, and all. And the same trend, if it's continued, then naturally internet creates more data, and then interprets data, which in turn again creates more amount of data. So you will find that this is there now. If this data is to be processed, why people will prefer for computerization or automation, etc., because the cost of computational power which is required for this type of purposes is also falling steeply, or it has become very competitive. So the cost in which 5 years back you were getting a machine with just simple processor, in the same cost now you may get a machine with multi-core or GPUs or whatever facilities, so that it can have more computational powers and all. Therefore you will find that data mining is very important, and in that, when classification activity comes, then you will find that it takes input from a process called as learning, and as an outcome of that it can generate rules for required for clustering or classification. Now, in this case, you will find that in this block, if the classification is done, there can be two types of outcomes which are coming out of this activity. Either it will help us in decision making, or it will help us in prediction. So when in the system as input, if the symptoms are fade, then you can decide whether it is dengue, chikungunya, COVID, what kind of infection is this, because they can have similar types of symptoms. And in that case, prediction means when there is a mathematical model done, and based on some trend, if you want to predict, for example, which share after 4 days or in some few hours would catch high price or can give you good returns and all as far as monetary investment is concerned. So this kind of predictive job, or whether it will rain day after tomorrow or not, this kind of prediction if are to be made, in which no classification is involved and more of prediction is involved by studying the trend in the data, then that analysis is to be done. So both these kind of outcomes can be achieved from the phase of classification only. Now, when such thing is there, we can understand that how important pattern classification is. and what are the challenges in that. So first thing is a very large size of data as per as complexity and also the dimensionality or variety of types of data. For example, you can see daily the kind of videos we see. As you change your mobile phone and evolution in the technology is there, the mobile the videos recorded or captured are of higher sizes, higher resolution and all. And secondly, not only that, you may have to process audio, video, so many types of data, and also there can be complexity also. Then you will find that whenever we are processing the data, three types of challenges we always face. One is consistency. Now you may be surprised that why consistency can be a challenge basically. So you will find that consistency leads to a lot of redundancy. If it is not exploited, then surely it can affect the efficiency of your system. Inconsistency can bring lot of vagueness or ambiguity in the data. So for example, if you are making a medical medicine diagnostic system, and suppose if you have kept in mind that we would feed the features or the symptoms and it will tell us the diagnosis. So for system, suppose if you feed like three symptoms are there: high fever, nausea and cold. Now in this case, these three symptoms you see are not just uniquely present in only one type of disease or ailment. They can be there in any other type of ailment also. For example, fever, nausea and um, cold can be there in malaria also. It can be there in pneumonia also, or it can be there in some other ailment also. Now problem is in this case, if we take these features and try to do the classification, then there is every possibility of having higher amount of error resulting into misclassification. So what here can happen is the same values of attributes are there, but same values or attributes are resulting into different classes, and therefore lot of inconsistency in the data can be there. The data can be imprecise, it cannot be precise. That means the patterns when are repeated every time you are getting mapped to a different type of class, there can be ambiguity or vagueness, or even missing data can also be there. So your ill-defined or partially defined or incomplete data can also be there. For example, if lot of occlusions are there in the images, then the region to be classified or segmented may be lost, or there can be lot of complexity in this. Secondly, you will find that if these are the challenges, then whichever classifier we should use, or rather we would use to classify such type of data, should have these kinds of capabilities. So first is you will find that it should be fast enough to provide decisions in a real time manner. For example, tomorrow if you design a classifier and if you say that it is 100% accurate, but and you it is used for medical diagnosis system, so you will say that it is 100% accurate, everyone would be very happy. But the other side of the story is, if it happens that if it is giving you the correct answer after 2 hours, then it's of no use, then it is very fatal, because till that time the patient may face death. So we want instant answer as soon as the input are given, and therefore the convergence of the learning algorithms also should be very fast and decisive one. Therefore it should be fast. Secondly, the intelligence possessed by the human brain cannot be challenged. So the level at which it possesses the capability to make decisions and all, same kind of capability is expected from this system. So we would say that it should mimic the human decision making capability. This is very challenging and tough job. So you are expecting a machine exactly to behave like a human being. So in that case, you see, we say that a few doctors are very intelligent. So many times we discuss cases of our relatives and all, that there was no pain, but he or she was sweating a lot. But the doctor immediately could know that this is heart attack, and they give since the in time treatment was given, the patient could be saved. This happens because the human brain is very intelligent. So many times the pictures which are seen or the attributes which are fed in the system are quite deceptive, but they could make it that even though such and such type of circumstances is there, their conviction is very good, and they do not agree with the general conviction of the result, and they would say that no, I feel that there is some problem, and they will give that kind of treatment. So this kind of human decision making capability should be present even in the artificial system also. So if there are exceptions, they can handle that and all. Then naturally its accuracy and efficiency both should be very high. So it has to be, and in case of many sensitive applications like medical diagnostic and all, this accuracy would required would be more than 99.99%. So you will find that and secondly, such type of classifiers usually can or should be able to handle all type of data, whether it is consistent, inconsistent, or incomplete. So the process of classification should be carried out. It should be able to deal with any imprecision or vagueness in the data which is present over there, and also should take care of the redundancy present in the data. So you will find that then few more characteristics are there, that it should be synthesizable, it can we should be able to implement it on hardware, or you will find that its implementation over it should be minimum. It should also run on very simple type of hardware and all, and its requirement should not be high. So these are the general characteristics which are there. Now for classification, there are n number of methods which are available. So this is a very pioneering paper published by Dr. Anil Kumar Jain, and it's a very good review paper which takes stock of all the classification techniques using different tools and all. And for data mining, various sub processes or methods are there. For example, whether you are discovering the associations, or whether you are carrying out regression analysis, or whether summarization is to be done, or clustering is to be done. So then he has already done a wide variety of research or review, and has provided different kinds of techniques. That is the case. So whereas clearly you can see that for the classification has been highlighted. So from literature survey, we have seen that neural network C4.5, rough sets, genetic algorithm, cart, kin, nearest neighborhood, Bayes classifier, fuzzy logic. These are the kind of the standard conventional methods or tools which can be used for classification. So our focus would be on rough set. So go through this paper. This is very interesting, and you will find a lot of interesting information in that. Okay, so now next is you will find that amongst all possible method, the first approach or most popular approach is statistical approach method. But every method would have few good points and few weak points, so with strengths and weaknesses. So if that kind of analysis is being done, then you will find that the problem with the statistical approach is it is popular, widely popular mathematical methods of the knowledge interpretation or classification and all, but it totally lacks the capability of mimicking human decisions. So if very intricate, complex data sets are there, then its decision making capabilities may not be of the order of a human brain. Secondly, these methods fall flat on their face when the dimensionality of the data is very high. Or the size of the data is also very high, especially when unlabeled data is there. To handle such data and all is very problematic as far as statistical methods are concerned. So like principal component analysis or these kind of methods are there. These are statistical methods. So that's why you will find that some other methods people started exploring and preferring for classification techniques and all. And over the period, those methods also got evolved, explored completely, and we could know even their pros and cons also, or strengths and weaknesses also. So you will find that still statistical methods are present, or they have a dominating presence as far as other applications and implementation of AI ML based techniques for that is concerned. You will find that that's why it is a very good element for or member for hybridization processor. So statistical approach in individual capacity may not be able to give you the desired results, but when they are combined with other methods and all can provide you very good results. Then you will find that fuzzy logic is also there, whereas now as compared to the statistical method, fuzzy logic would be more capable of mimicking human decision making capacities. Secondly, it can handle the vagueness in the data or missing data very well, because here the attributes are presented in terms of a linguistic description, in terms of variable and all. So you will find that it can deal with various kinds of problems where your traditional methods cannot be used, and you get a better control. Now you will find that the drawback of, or you may use fuzzy logic for this technique for certain automation or mechanical engineering related technique where updation rate is not so fast and all. Fuzzy logic based techniques are very useful. But when it comes to integration or hybridization of fuzzy logic based method for other databases and all, they fall flat on their face. So this is all because the platform which we have assumed does not have a generic nature, and it is we who will have to explore it or study it, or we'll have to do a lot of research if we want to get it done through fuzzy logic. Another thing is, for every task, fuzzy logic is suitable is not so. Means for some cases, statistical method would be suitable. There you will find that the fuzzy logic based method may not be suitable. So you should be able to judge properly, and you should evaluate or completely find out the nature of the problem, and then you can decide which kind of tool you want. Now, in this case, you will find that the genetic algorithm is also one such tool which is very efficient, adaptive, and robust, and especially very useful for search algorithms and all. So you will find that it optimizes the computational requirements also, and robust and fast or approximate solutions can be obtained instead of closed solution. But problem is genetic algorithm based methods are computationally very intensive. If you just do the big O notation analysis of the computational complexity, then it can be most of the time more than n square or n by n square would be there. So and secondly, the convergence also is delayed. Means once the convergence is there, you will never come to know whether you are at the global minima or local minima of the solution. So you may feel that okay, the network has converged and the outcome is valid, but at next stage itself you will again see that the error is still coming, and therefore you will find that many times the delayed convergence is there, and we many times assume the local solution as the global solution itself, whereas still further processing, after certain further processing, you can get the ideal solutions of those problems. Now, artificial neural network, this is a very popular choice as you have taken the theme of the workshop as AI ML. Ultimately, it is what? So you might have gone through various lectures so far, like convolutional neural network or deep neural network. So you will find that these are all varieties of making various layers to work, increasing the depth of the layer, making hybridization of the type of the layer and all. And but you see at bottom ultimately it is all nothing but neural network. Now you will find why neural network are very useful. So the biggest strength of neural network is generalization. It can be applied to any kind of problem, or even problems where other tools have failed. They can well imitate the human decision making capabilities, and you will find that the most wonderful strength of neural network is they can work even with noisy data also. So you will find that they are less affected, their accuracy is less affected for noisy conditions once they are trained. And therefore, you will find that the uh, neural network, as it is a population based technique, generally its search for the solution is in random manner. Now you will find that you in under neural network, either you can use supervised or non-supervised or unsupervised approaches. So you will find that sometimes the solution may be deterministic, sometimes the solution may be non-deterministic. So these are all points related to use of neural network. And another thing is, if you see the limitation, there are just one or two limitations which can be easily removed when the tool is put in hybridization with the other techniques and all. Then you will find that you can easily get the solution. So it also has limitation. It's not the case that neural network does not have limitation. It also has. The first limitation is exhaustive training is there, so which is one time activity, and unless the all the weights are convergent, the neural network starts giving desired outcome and all with the desired accuracy. Till that time you have to go through various iterations of training itself to train the system for various kind or variety of data. Then you will find that neural networks itself is a population based technique, and therefore it does not exploit the redundancy in the feature space. So sometimes what happens, if suppose for as an input you have taken 10 features for the system, but in that case you will find that out of that 3 can be same as the fourth one. So there can be repetition, and it all depends how efficiently you have defined the input parameters and their values and all. Based on that, this particular problem can be dealt with. Then if the dimensionality of the feature space is large and system is complex, then you will find that neural network may not be an apt choice for classification, etc. So then how to face this problem? So it was then found that if we use hybrid approaches, that means whatever popular tools are there for classification, if we can make a team of it, or if we can amalgamate technologies together, then definitely they would be very very useful. And therefore there is a, so in that case there is a scope of hybridization or unification of different technologies. So what kind of combinations are available? You can have solutions which are fuzzy logic and artificial neural network based. You can have neural network and genetic algorithm hybridization together. You can have fuzzy logic and genetic algorithm together for retrieval type of algorithms and all. Finally, you will find that you can combine all three, that is artificial neural network, fuzzy logic, and tools like genetic algorithm in that, and can very well develop a very good product which is commercially viable also. Or you have designed it for such a critical application where for first 2 years there will be a lot of number of clients to buy that particular product or to commercialize it and all. But at the same time, there are two strains, like they are very generic in nature. So when neural network is applied, it will never be done that okay, for this type of problem use this neural network, and after this it won't be useful and all. This kind of thing won't happen. You will find that since it is generic in nature, for any kind of problem neural network you can use. And generally their criterias or whatever we design, they are always application specific. So suppose tomorrow if I design a classifier which is giving me the response for certain inputs and all, but there is one more this kind of system where for the same input everything is same, still that system is not giving the output. So if this is happening, that means you have designed a solution which is application specific. For example, face recognition system if I have developed, can the same system or code or algorithm be used for identifying the fruits on a stall which are robotically to be picked up and all? Now these two things are quite different. Identifying a fruit is quite different than identifying a face. So the kind of characterizing features we would get and all, their values and ranges would be quite different and will be application specific. So therefore you will find that if hybridization is to be done, then always you have to keep in mind that there is some calculated risk also. So what we did, we studied almost around 400 papers as secondary publication or review papers and all, and tried to plot a graph. And then we could realize that hybridization approach in the papers is found every now and then, and is a very popular approach. Whereas 35% still use artificial neural network, and 10% of them use the statistical technique. 8% have recently started advancements in fuzzy logic, but slowly I think this area would also get added up to the first area itself. So you will find that this is the extent of use of various tools technology. If 500 research papers are studied, you get this kind of diagram. Then you will find that one way we can conclude is uh, there are different types of methods, and they would be like creating a situation where the particular system will have to play a specific role, and based on that the outcome would be there. So you will find that in this case, we have seen strengths and weaknesses of various other tools for unification or for hybridization to give a new course and all. In that, we have talked about fuzzy logic, neural network, or evolutionary algorithms and all. But we haven't talked anything about rough set. So now we would introduce at this stage. And rough set is very, very, what I will say is a useful and important tool. Now, this is a kind of, you can say, uh, expert system at central level, or this thing for various tasks to be performed and all. Then you will find that these expert system can be comprising of fuzzy system or neural networks or genetic algorithm based techniques and all. So if we compare for task wise what is the outcome with this tool and all, then you see white means it is bad, and next gray without any number like 1 and 2 means it is still bad, though it is not very bad. Then 3 onwards means it is good, and fourth means it is better or best, you can see. So let's say for example the um, neural network is concerned, then you will find that as far as knowledge presentation is concerned, you will find that fuzzy system can get score up to 4, statistical technique can go get up to 3, genetic algorithm it's bad means generally it is not getting any score, and neural network is also bad. So like that every tool you can evaluate from this characterization and can know its weightage particularly. Now, you will find that what kind of challenges the data presents to the classifier as far as classification activity is concerned. So that I have already discussed: vagueness, incompleteness, then imprecise nature of data, and consistent data or inconsistent data that we have already discussed. So I won't repeat it again, but these are the characteristics of the data which makes the or which affects the entire procedure. So now we can conclude that with this discussion that roughset is really a very good tool which can be used for hybridization, and if it is present over there then it can help or boost in terms of results and quality of whatever algorithms or methodology or product we would be developing. So you will find that roughset is the most suitable candidate for such kind of hybridization. So roughset hybridized with conventional technology, we can get very good systems which would work as per our desired features or characteristics. So you will find that we would try to explore the rough set this thing. But now then thing is, if rough set philosophy is applied and main thrust is given, then what kind of activities we would be in a position to conduct if the hybridization with the rough set is being done. Then you will find that one you can do is the attribute reduction to reduce the dimensionality of the problem. You can either do or get design what rule generation and prediction based on that. Then you can also come to know about the significance of the testing and rule validation and all, or rule generation which would be done with the rough set and all. And then you will find that the data discretization or grouping of qualitative values, this kind of sub processes when are there, then also how you act accordingly, or how you use the rough set for all this kind of hybridization and all. This would be tested. So you will find that rough set generally we are taking its name every now and then. So there can be people who may be amused or must have curious or query in mind, or they must be curious enough to know what is rough set actually. So rough set generally you will find that it is regarding under the umbrella of soft computing, and you will find that in terms of artificial intelligence, it's known as a one of the five key parameters or in the traditionally known areas and all. Then that does not mean that the other soft computing methods are completely useless or something like that. They have their own limitation. But here now we are proposing that if RoughSet as a tool can get hybridized with other tools, then the result generated will be very encouraging. So it is RoughSet is unique. It is discrete in nature and all. Now, again, one pioneering paper is there. If that is referred, then you will find that there are various activities, and its scale also can be known, whether it is a microscopic activity or macroscopic activity. And secondly, when classification is to be done, which type of bas- uh, basic platform we are using or characteristic we are using, whether the methods need to be deductive one, or whether they need to be inductive one. So based on this, you will find that if your method is deductive and microscopically, primarily numeric in nature, then you can use chaos theory. If your what I would say system is inductive and again microscopic, primarily numeric in nature, then you can use neural network for inductive purposes. Deductive purposes, chaos theory would be there. Deductive means when you want to form clusters, and inductive means you want to bring different cluster together to make a larger object or something like that. So fuzzy logic when is used, then fuzzy logic we can see it is macroscopic and descriptive in nature, but it is a deductive kind of technique. It is not inductive kind. So as it is deductive kind of technique, we again see here lot of time would be taken in membership function finding out or planning and all, and therefore we want certain lucid method which can take care of all these aspects. So if that lucid method, if you consider, then definitely the answer is rough set. And rough set, what does is it himself never consumes the data, but it speaks about the data. So we get, you will find that data of data or metadata. So rough set has a peculiar habit that as soon as the data is provided to it, it would start to have compartments or you can say clusters, and it starts interpreting the classification, and therefore you will find that any variation in that, it will try to classify that object into one particular class. So this is always there. Now how rough set is, so you will find that rough set, our normal set is completely discrete or crisp in nature. So this is a to b are the bounds, and this is set for a output value of 1, let's say, or unity. So this will be the characteristic for the rough set based computation and all. Sorry, normal set based computation and all. If we go for fuzzy set, then you will find that see the limits are same, but this linear this thing has come. So it depends like whether your one node is Euclidean distance wise closer to another node and what. So to compensate that, there would be see here only two levels are there in first case, that is low and high, but here multiple levels are there. So you can say that it is 0, it is 1, but in between that these particular gradual level variations are there. So either it can be on the positive side or negative side, whatever it is there. So you will have to estimate the membership functions, and there would be a lot of computations involved over there, and after that the result would be declared. Therefore fuzzy set is very less preferred, even though it can take care of vagueness or imprecision present in the data. Rough set is between the two. If you ask basic nature wise and how the rough set is then you will find that rough set is digital in nature. So again, the diagram is of square, but this is rough set that you have to understand. So how rough set is formed? Rough set is a duplicate, and you will find that it is collection of those points which do not belong to a certain class or used for classification. So based on that, these boundary values or threshold values would be computed. So we can clearly see that for the same database where your regular methods occupy so much region, or persistent-based classification technique also ultimately has occupied the entire space. Whereas offset is of smaller size. You can see here it is only of this interval size, and it will have less space for solutions and all, but it would be crisp in nature. Now, moment it is crisp in nature, the good news related to it is rough set based all postulations we can directly implement using a simple programming language on a computer, and also it will make code synthesizable also. So that is how here the picture has been depicted, that let's say there is a system in which different classes are there. So to know the color, these different classes have been shown, and like that different stages have been taken. So you will find that these are all representation of you see, just a moment. These are all representation of the processes or sub-processes involved in rough set and all. Finally, you will find that in terms of a lower approximation and upper approximation duplet, the rough set for the given set would be obtained. Now, U of t or upper approximation of the given set is nothing but having all those elements in which one particular section or class of object is not 100%, 500% belonging to the required class, and the other number of objects are nothing but boundary line cases. So it's not sure whether they are not whether they are or they are not the member of the given class. Whereas lower approximation, you will find that is only what I will say, collection of members which 100% definitely belong to that class, and others are not have been taken. So you can find here these three amoeba kind structure, pink in color or red in color, are present in L and T. They are also present in U of T also. So upper approximation means the same, uh, the all the set of objects which belong to the given class. Along with that, you will find that the borderline cases or what other objects are there which we don't know, may belong, may not belong, or this decision is dependent on something, then there is a clumsiness. So what we will do, we will form upper approximation of that particular class. So these two sets together, that is U of t and L of t together, if we form a set, that is called as rough set. Now, the advantages of rough set is you will find that it can work in measurement space or feature space or even decision space also. Secondly, it is a form of granular computing, so there is lot of scope of parallel computing and all to increase the speed of computation. And the biggest strength of rough set is it can work with any kind of data. That is, it can work with inconsistent data, consistent data, incomplete data, or you will find that some other type of data, if it is there or variety it is there, then also this particular rough set can handle, because its own nature is data independent from the postulations or rule generations which we have already done it using rough set and all. It will only use that and will go on classifying the things, etc. So you will find that there are a lot of advantage given. These core redux I will explain you separately. So in this case, you will find that these are the advantages given. So with this discussion now, we are almost sure that okay, agreed. Rough set is a good tool and it should be used for hybridization as far as classification activity is concerned, and therefore it is a very promising candidate. So what we will do is, if hybridized systems is there, what will happen? Original data out of that feature generation would be there, and the outcome would be provided to output model, and there can be reduction in the dimensionality of also. So feature reduction could be done. So this output model will give finally the decision, and iteratively this cycle would be repeated after every some interval of time. So we have talked about enough about rough set. Now question can be, okay sir, for any application of classification and all, if this is to be implemented, then what is the procedure and what are the various factors related to rough set, and also just let's have a very quick overview of the terminology of the related to rough set. So first is the information system. An information system is nothing but a table in which your entire data is there. So I would directly go to the example, and you would understand information system is always indicated with the help of letter I, and it is actually pair of U of A, U and A. So basically U and A are nothing but the condition attributes and decision attributes in the table. What do you mean by it? For example, this table is having a data of optical characters. I think some 40-50 types of fonts are there, and related to those fonts 26 alphabetical letters are there, A to Z, capital or small. Regarding that, some features have been already computed. What is the mean of that image of that letter? What is the mean deviation, variance, sigma, skew, then sorry, skin color. So this may be related to face, but we can do same for optical characters also. So it is face, it might be face related. So what is value of sigma h, sigma v, like that it is there. So these are all nothing but features. So you see in table, the table heading which is given on the top is identifying the name of the feature or the characteristic. So you will find that these mean deviation, variance, sigma, skew and all are called as condition attribute. Condition attribute means these are features and their value. And you will find that each row is one object. For example, first row is the first face, first figure or picture or face of first person. Related to that person, what are the values, different values of various parameters as far as first person is concerned. Now it might be the case that the face figures which are to be classified, in how many number of classes they need to be classified and all. Let's say 10 classes are there or 9 classes are there. So what you are doing is you are each row, like you are classifying it and giving a label to the classes. So first row sample is belonging to class number 1, then 2, then 3, then 4, then 5, then 6, 7, 8, 9, like that different classes are there. Now you know here the integer values or plus and minus values have been shown with sign and all. Sometimes you will find that your attribute can be completely binary in nature, 1 and 0. So whether they are there or not there, like that it can be there. Sometimes you will find that some integer real values can also be there, like that whatever way the parameter has been computed, and these are the class label. Or you will find that sometimes it can be linguistic description also. For example, instead of mean we will say fever, high fever, headache, nausea, loss of appetite, like that the titles are given. These become conditional attribute, and below that for every patient, one row is one patient data. I would just write 1 or 0 or yes or no or y or n. Now this is binary nature, discrete nature in interpretation of the feature. So in that case, high fever, if I write 0 here, that means this particular patient does not have high fever. But suppose it has headache and a loss of appetite, then there I will write 1 1 or yes yes. And then with this I would write here that this is nothing but typhoid. So typhoid is one class. Then I would write chikungunya, then dengue. So these are the classes in which that patient has been already classified basically. So it is a labeled class, and these kind of attributes are called as decision attributes. So whenever you want to use rough set for classification, then the first thing which is required is you should have a table like this, and this entire table then is called as information system. So whenever rough set based classification is to be carried out, then you will find that you must be available with the information system. Then you will find that the set approximation, as I have said, that this is your total domain of discourse, which is the case. And then there would be one set A of X with upper approximation, in which you can have all those objects which for a given class may belong to it or may not belong to it, means it is clumsy. So you can have all such objects which they do not belong to that particular class. So that's why it is outer region. So a bar of X, you will find that a upper bar of X, like that it is there. So this gray area is containing all the objects, such objects which for which you definitely know that they do not belong to the given class. For example, if I say typhoid, related to typhoid is the given patient is not in the class of typhoid, then it will come in a bar of X. Similarly, in the given database, you know for a given class the objects which are 100% belonging to it. As soon as you see the symptoms, you know that this is beyond doubt malaria. So if I am discussing class malaria, then all those patients, you know definitely they are belonging to malaria, will come in this blue region. So blue region is called as lower approximation. That means collection of all those objects which definitely belong to that class. Gray area is collection of all those objects which do not belong to that class. So what will happen if I subtract from the gray region the blue region? There would be a green region, boundary region, which would get defined here, green region, which would be like a bar X minus a cap of a lower bar of X. And this boundary region, green region, is a duplet which will have a pair of element which is borderline case, and it may have element of upper approximation as well lower approximation, and therefore you will find that this is called as rough set basically. So all this green region is rough set, which is crisp in nature. So these kind of sets when are defined, these are the, sometimes they are also called as positive and negative region or a boundary region, like that it is there. This way also you can show. So a lower bar of X white region is the positive, that means collection of all those objects which definitely belong to that class. Negative means do not belong to that class. And if from this entire negative this thing and minus this lower approximation, if I do, the blue shaded region of boundary would be obtaining, which is nothing but your rough set. So you will find that. Then secondly, redux, this is also one more term. So in this case, this is optimize or minimize number of attributes which help us to take the decision where for the given set of attribute the known object belonging to that class or not. So you will find that analogous example I will give you is you use K-map or Karnan map and you get a minimize function. And suppose if the function is of f of a, b, c, d, then the minimize expression may not have all the four variables in that answer. So it is a minimize set basically. So reduct means it is minimize set of attribute which helps you in classification or to take the decision whether the given object belongs to that particular class or not. Now, if someone asks you that the answer of K-map, is it unique? The theoretical answer to this question is no. That means when you enter the logical function in K-map and try to solve and get the answer for minimize function and all, you may get more than one solution. So it is your choice whether you want to have the vertical pairing of one or whether you want to have the horizontal pairing of one. And because of that, you may get two solutions. But both solutions are correct and equivalent or not, how we would decide? Simple. The total number of terms in both solution would be same, and the number of terms in each term also, or variables in each term, would also be same. So when you compare the two, then you will find that some common terms are there which appear in both answer. That means they are unavoidable. They would always be present whenever this classification or clustering is carried out. And such this thing, you will find that this will be subset of reduct. Reduct already is the optimized set, and from that also there is some set of attribute which always you will find in that pair or grouped or whatever this thing grouped group of attribute. Then such group is called as core which is inevitable, which would always present. For example, we use Queen-McCluskey method and we find out the prime implicant of a logical function. The prime implicant are nothing but core here. So whenever information system or table is provided to you, whichever set of attribute you get which is for classification is very essential, and you will always find that they are always present there. It would be core. So you cannot reduce number of attribute below core. Then you will find that when you are comparing one object with another for a given set of I will say given set of attributes or something like that, then you will find that there would be a discernibility. Discernibility means whether this particular object in terms of its attribute is related with another object or not. And if they discern from each other, surely it will be easier for you to carry out the classification. Your accuracy would be higher. So you select such type of set of attribute that object classification or finding out or exploring its discernibility would be very easy for you. And therefore, if you have n row, n this thing, n number of objects in the information system, you will find that an n by n matrix would get defined where each row getting compared with another row to explore the discernibility matrix and all. So you will find that, as I have already said, rough set can process inconsistent, consistent, and incomplete data and all. So various kinds of postulations or rule generations or approximations we can do as far as rough set is concerned. So now a lot of mathematics was there, and due to paucity of time, I cannot enter into the details of the algorithm also. But I will show you directly the results in terms of applications when they are provided these hybridization results, what kind of outcome they give. So let's go for some hybridization. So here you will find that Shankar K. Pal from Indian Statistical Institute of Sciences, Kolkata, is an eminent professor from there. And you will find that this was his first transaction paper in which there was some classification task for flower images or speech data was there. And it was a 3-feature 6-class system was there. So you can see MLP is multi-layer perceptron, then fuzzy multi-layer perceptron, then multi-fuzzy multi-layer perceptron, then rough fuzzy multi-layer perceptron or modular rough fuzzy multi-layer perceptron. Whenever rough comes in picture, you can see the enormous improvement in the parameter. So here you will find that training data of 20% to testing data of 80% was used. And you can see the classification accuracy. So you can see multi-layer perceptron pure neural approach when is there is hardly around 60%. But when rough is given, this purple and white color bar you can see is almost tallest or is having the highest accuracy, touching 90% or more than 85% or so. So here you can clearly see that these accuracy are very higher whenever rough set is there. Secondly, network size you can see. So when the neural network is to be implemented, the network size you can see the reduced number of links are there. Here you can clearly see whenever fuzzy computing or fuzzy logic is used, the number of links are highest. So red color bar you can see, whereas white you can see the rough set base when approach is there, it is the lowest you can see. So number of links, so network size is reduced rather. So if you go with rough set, your network size would get reduced as far as pattern classifier is concerned. Training time also, this was older data, so that time 400 megahertz was alpha station also was supposed to be this thing. But in that primitive research also, the usage of rough set could be explored, and here you can see that the training time with rough set approach is very, very less, whereas for fuzzy it is very high, which is quite obvious because whenever you use fuzzy logic, you have to compute the long membership function which are required, and it takes lot of time. So you will find that this is very much evident that your training time would also get reduced if rough set is there. Now, if a pattern classifier is there, then in what way I can use rough set and all? You can use it in multiple ways. You can use it for pre-processing. You can use it at training level. You can use it even architectural level also, like your convolution neural network, deep neural, and also you can, if the new architecture is to be defined and if it is to be optimized and all, you can use rough set philosophy there. At training level also you can use. And how quickly I will take a review and would show you how it is done. So pre-processing level, how it is used? It is used for reducing the number of attributes basically, which is a NP-hard problem, non-deterministic polynomial, or like a traveling salesman problem, and is very difficult. So how you can do selection of higher important attributes and all. So this is the example, and here the data set of a semiconductor industry was used. So the wafer were have to be classified, and there were and like large number of input parameters where their voltage, current, leakage current, temperature, ambient temperature, then cutoff voltage and all like that, it is there. So all of the attributes, if you are really you are using every time for the classification, then you have to explore whether all of them are required or not. So you can do attribute weighing and can decide really at like the accuracy of the classification depends on which particular factor. So we may not necessarily feed all the input parameters to the neural network. So prior to that, at pre-processing level, if you use a rough set data analyzer, then you can decide exactly how many number of attribute you should feed. So symbolically it has been shown that only two parameters, it has weighed it and have taken decision that look, voltage and current only would be values would only be contributing most to the accuracy, so the other attributes won't be taken into consideration. Otherwise it would computation become very intensive, because it would be n by n square computation complexity would be there, which would be a NP hard problem. Therefore attribute reduction at pre-processing level is a very welcome idea using rough set analysis. Then you can even carry out discretization also. This I would just skip because it is a subtle stage of pre-processing and lot many algorithms are to be described. So I don't have time for that. But some interesting result I will show you. So here you will find that at learning level also we can use. So if your unsupervised classifier is there and you are using winner take all algorithm, then what you can do is the output node for which the response is maximum, you will update the weights related to it, and rest of the node weights would be updated in the relationship, basically depending on the Euclidean distance from the output response of the winner node of other node. But this is like membership function computation or calculation, or it is a fuzzification of the learning algorithm, which of course is cumbersome and will take too much time. We can improve this algorithm and we can use rough set philosophy at learning level. So what you can do is at learning level, again you can carry out the or find out the values of the thresholds for these two important parameters, and you will find that the learning constant you can decide which is to be taken. And if at learning level, if you are providing the philosophy of Russet basically, so you will only have lower approximation and upper approximation, and cardinality of the correct decision if you compute, then you will find that you will only update the nodes related to two approximation as far as rough set is concerned, and there is no need to update all the nodes. And based on that, the early convergence can be obtained. Then, as I have said, as I have shown you the example in which the number of links also got reduced because of use of rough set. Same here at architectural level, what we can do here, we design two approaches. A normal neuron in the artificial neural network is there. We have defined a rough neuron, and much of the work was done by Dr. Lingras for supervised this thing. Then we explored for unsupervised. And here the idea is actually a rough neuron would be comprising of two neurons, and it would be taking inputs of upper approximation and lower approximation. So one neuron would be given inputs which will have the entire set of input, and another neuron would be given input which will only have cores or the important attribute required for the classification. As you know, core of information system means only minimize important set of attribute which is finally required. So combining the two, the output response would be obtained, and finally it would be decided. So based on this rough neuron, we have designed a new kind of architecture. So here this concept you can introduce in your deep neural network, or you can see you can introduce it in convolutional neural network or multi-layer network, deep learning, whatever is there. So you see normal neurons have been replaced by rough neurons, and then we could see what kind of improvement is there. The input neurons, we have kept it conventional neurons only, and surprisingly the performance was improved to a larger extent, and accuracy also got enhanced to a very larger extent for various kinds of application. And then architecture optimization also. So the architecture size of the neural network itself you can prune or reduce, and that was done by using rough set philosophy. So due to paucity of time, I won't be in a position to explain these equations and all, but the bounds of the errors were worked out that if you remove one particular link, at what cost the accuracy of the system would be affected, and you can take this decision based on rough set, and such kind of algorithm was designed. Now based on this, you will find that the number of links or the size of the neural network taken also gets reduced, and in an optimized manner, with less number of layers you can have higher accuracy as far as rough set philosophy at architectural level is concerned. So you will find that even incomplete data processing can also be done. So I will better show the result of this. So you will find that in this case, these are the applications. So optical character recognition. So a database is there where you have images of various letters for various types of fonts and all. This is the pre-processing, cropping, binarization, skeletization, etc. Number of loops and all. And with pre-processing, you see you can do pre-processing based on rough set, and final information system is obtained. This is very good example of consistent data on which rough set philosophy can be used basically. So this is one application. Another is face recognition. So here you will find that the database which was there from IIT Kanpur and Amitabh Mukherjee and Vidit Jain. So you must this thing university collaboration project was there, and the Indian faces with various angles. The pictures were captured, expression variation were there, only occlusions were not there, and at the same time you will find that even the we can say is expression variation were there. Illumination variation was also there. So some pictures are bright, some are darker, like that. So with that, some pre-processing was carried out, feature extraction was done. Again, the information system was obtained, and from that it was used with pure neural approach, then rough set based learning level approach or architecture pruning and all, and these results were carried out. So I would show you the results actually in terms of application which was developed. This is all about learning and convergence of the learning constant and all. So just a moment, I will show you the results in terms of application that would be more interesting. So you will find that yeah, here you can see. So number of iterations you can see when rough set is there, how with redux and all it reduces. So pure neural approach is there, almost 1000 iterations are required with learning constant rate of zero point 0.4, and accuracy is 94.78% for character recognition project. Whereas when pure neural with redux were used with pre-processing technique, with same learning constant, the accuracy is slightly compromised, and iterations also remain same. Here you will find that rough neural, if we use even with a smaller the learning constant, the accuracy better than this in lesser number of iteration we are opted. So we can see here that in this particular project, the architectural approach based on rough set philosophy is quite helpful. Then also you will find that in case of face recognition, the same kind of comparison was done. So blue is pure neural, pink is pure neural with redux and rough neural, and you can see the convergence. Almost you can see the last part, the consistent performance is there around 95% as far as architectural this thing is concerned. So this is epochs and accuracy comparison for face recognition with learning constant of 0.1. Similarly, for the handoff prediction application for 4G mobile network and all. So that also you can see. And again, the comparison in terms of number of computation with accuracy and all for face recognition system you can see here. So handoff prediction also you can see. So as you can see, the architecture size is reducing almost with 6-link, 4-link architecture. We are able to get very good accuracy, and number of computations also moderate enough to get the similar kind of accuracy and all. Now, in this case, the application-based outputs would create more interest, or it would be easier for you to understand. So if you select the data sheet, information system is selected, and if rough set based classification is carried out, then you can get the pre-processed data. Similarly, for character recognition also, like you load it, then you select the reduct algorithm or the discretization algorithm, or whether you want to classify it with pure neural or with reduct or rough neural and all that you select, and based on that the results are obtained. For face recognition also, the interesting feature is, see, input image if we are giving, then the output image with whatever time they elapse for recognition or classification and all will be shown. Now here you can see the input image is given, imprecise data is there, and feature space reduction technique is used. So you see the photograph which has been searched as an output is different, and expression in variation is also there. So method is very good. Expression invariant means in first photograph the pout has been made, second photograph the illumination is also better, but same person is again identified. Now even the various cores which have been suggested by the rough set philosophy, if you take that, then pure neural approach or other approaches, they fail if the missing information is there for rough neurons. So you see input image and output image are differing because some of the characteristics or features are missing. This is again incomplete data testing. So when that happens, if you do it with the help of rough neuron, then even with incomplete data, the identification or classification would be done. So rough set basically can handle any kind of data, even incomplete information is there or occlusion is there in the images and all. Still, it can very well do the recognition or identification. So this is another sample of missing data. If you use again normal neural approach, the outcome would be wrong. If it is there, then see again. So upper image, the illumination is lower. The angle is also different. Still, it can make out and identify the person. So you will find that then handoff prediction, like again same thing, 4G network or 5G. If the cell size is going to reduce a lot, then you will find that for frequent handoff in micro cells, you can predict where the handoff would be. So for prediction also rough set can be used. And this one small research approach is there where rough set based data processors or accelerators or what we can say is controllers have been designed. So one of my PhD scholar who is now assistant professor in Wadia College at Pune, she has designed controllers using FPGA which are on rough set based philosophy used for real time discretization or data pruning and also these kind of controllers would be very very helpful. You will find that in case of um, computer vision applications or real time processing of scene analysis and all, then you can use it for medical image segmentation also. These approaches are also based on rough set. So here you will find that again rough set based philosophies can be used for computer aided diagnosis. So the benign or the cancerous tissues can be very well identified from digital mammograms and x-rays and all. So good papers have been published by Mrs. Vibha Bora, another PhD student of mine who is now assistant professor in Raisoni College, associate professor in Raisoni College. So these papers you can reform, but I'm just showing you that neighborhood or other classification techniques which are there, clustering and all, how their efficiency and accuracy increases basically. So Tosu algorithm or the boundary forming algorithms which are there, These are all implemented with the rough set philosophy, and they have brought an improvement in the accuracy basically. So you will find that whether it is MRI image or digital images and all like that, whatever is there, if rough set you use, the hybridization approaches can give you a lot of good results. Pruning of network, increase in accuracy, also reduction in you can say network architecture and all. And further now you can use futuristically these processes for degraded image restoration, image denoising, or multispectral image classification and all. So if you use these approaches, you will find that this is very good. And as I have said, one of my PhD scholar contribution for designing actual controllers and all. So I will just show you this. We have already discussed. So rough set computation, for that she has designed hardware for it. So these are called as hardware accelerators, and they have been implemented on Spartan FPGA. So you have fuzzy controllers in ACs and all. So futuristically, we can have rough set controllers also. So this is all experimental setup which has been shown here. And the smart grid control you can carry out. This was the application for which the data was real-time processed with the proposed design of the accelerator and all. So these papers are also published. You can go and see the details. So this is the actual setup. So offset-based accelerators, as I have said, these hardwares can be used for real-time data processing in image analysis or computer vision, robotic vision, and all like that. It is there. So system on chip also can be designed with this. So with this, I would stop here and have tried to give you a glimpse of the advantages which you can have for your classification activities under any higher level activity which you are doing involving AI and ML. So I would conclude that all these tools, whether fuzzy, rough, they are not competitive but rather are complementary. And you use such tools in a hybridized manner, it will enhance the performance of the system. This is a photograph of mine when I had an opportunity to meet Lotfi Zadeh, who was father or who invented fuzzy logic and all in University of California, Berkeley. So at US in 2008. Now, of course, he is no more at the age of 90 plus. He died, but a very hardcore researcher and a very pioneering person. So that was a special moment which I had enjoyed in my life. So thank you. And if any questions are there, then I am there to answer it. Thank you. Thanks a lot.
Thank you so much, sir. Thank you for your experience and especially for your time for sharing with us. Sir, if you wish, you can share your PPT with us.
Yeah, there are certain informations which are related to patents and all that I will exclude and will give the PPT to Somesh. There he will distribute to you.
Okay, okay. Thank you so much, sir.
Yeah.
For participants, if you have any kind of doubt or query, you can ask with Dr. Ashwin Kothari, sir.
Yeah, so there is one query from Dilkeshwar Pandey, which is there. Why we take 20% in training, 80% in testing, while in ML we take 80% for training and 20% for testing. So in this case, always I will tell you that uh, as I have said, there is a paper by Anil Kumar Jain, so you go for it for classification techniques and all. What happens is I have talked about the tools which have supportive roles towards this technology. And if ML, if you consider, then already the number of layers you increase so much that all the pre-processing which I am describing is already done by the multiple layers which are involving over there. So now looking at the application, you will have to decide whether you want to go for pessimistic estimation or optimistic estimation. These are the types of estimations which are there, and depending on the type of estimation which you are using, there is one holdout method also. For example, if n number of data is there, then only one sample will be used for testing, and n minus 1 would be used for training, and For further iteration, this would go on rotation basis. Every time one would be excluded n minus 1. These are different methods. So the statement which you are making 80-20 or 20-80 is very generic in nature. So basically, when you are implementing any application or project, you must first thoroughly understand the type of data and type of estimation which you would be requiring. And based on that, this percentage would be decided. So
Okay,
that is a classification pioneering paper by Anil Kumar Jain. You can read that, in which all these methods have been explained. So always, you know what happens. We use these techniques, and but we don't know the fundamentals. And in some paper, it has been done. That's why we also do it. Never do like that. You first go in depth, study it, and all. Your project might need a pessimistic estimation, so then the division of training to testing can be different.
thank you, sir. I hope Mr. Pandey sir has got his answer. Anybody else who want to ask something or any query regarding the session? I think no query from the participant sides.
Yeah, so they can get back to me at any time. Contact details are with Somesh, and also on my website, VNIT website, the link, the contact credentials are given. So you all are welcome for any kind of collaboration. Thank you.
Okay. Sir, excuse me, sir.
Yeah,
Sir, Mr. Suraj want to ask something, sir.
yeah, please.
Suraj, sir, please.
Hello, sir. Hello, sir. Sir, I want to know that
Yeah.
the output we are getting, the accuracy, what does it means, or the interpretation of the accuracy with respect to the result?
Yeah.
That
See,
we are saying
now here also it
98%.
is here also it is subjective whether your result analysis is for unsupervised method or supervised method and all like that it is there. Accuracy means basically how close you are to the required answer or the required response basically. So there are various ways, like people can plot box plots also. They can go for estimation of false negative, false positive. There are various ways to validate the result, and also based on this, typically in classification activity, we always see that how close our answer is, because the training and the testing would always be done for the labeled class data and all, and therefore your design system would always give some response as per the design architecture and algorithm. So how would you check whether it is working in your desired manner or not? So the number of what I would say, number of test iterations you have taken, for that you will be already knowing the answer, that this should be the answer, and out of suppose 100 expected response are there, out of that if your system is giving 93 responses which are correct and 7 are not okay or correct, then in that case the accuracy of the system is 93%. But it is subjective to some assumption. Now, what are those assumptions? That all depends on your experimentation, circumstances, and the kind of data which you are using and all. Apart from this, you can also validate the system by finding out false negative, false positive, like that it is there. So accuracy means, for example, now pandemic is going on. So if we do RT-PCR test, how accurate it is, whether the patient really is having corona or not, or it is just showing positive and all, how much accurate it is. So how to validate that? There are a number of methods. So you can have data of such say thousands and lakhs of patient. Based on that, some inference or accurate decisions you could make out. So that is how the accuracy we are finding it out. Now different projects I am showing. In case of mobile hand of prediction, the accuracy is related to whether I have given the optimized next cell or not. So this is the case. Or when face recognition is there, have I identified the correct person or not? Have I done the correct classification or not? If it is optical character recognition, whether the character has been recognized or not. Based on that, the accuracy would depend, and that is how you will mathematically estimate it. Hello, am I audible? So I hope this suffices your answer.
Yes,
Yes,
yes.
sir.
Okay, yes.
Yeah. So I am very thankful for providing
Hello.
me this opportunity for interaction and presenting my thoughts. So if
Hello.
no further queries are there, then I think we can conclude the session.
Yes, sir. Thank you so
Yeah.
much, sir,
Yeah.
for
So
sharing your knowledge with us.
thank you, thank you. I would leave the meet now.
Okay, sir. Thank you.
Yeah, thank you.
Dear participants, please give your feedback and quiz also. The link is active for another 5 more minutes. So please be quick and give your feedback and quiz also.